It's blank. Getting past the blank screen, right? That's the hardest part. I can honestly say last night, I wrote this presentation last night about 9:30 because I was doing everything in my power not to come write this presentation. Just couldn't get past the blank screen, right? So who had that blank screen? Right over here, here. All right. So yeah, sometimes you get a blank screen. Other times you get this, a little template. Add a title. How do I get past this step? This is the hardest thing. Just getting something on the page, something in the paper. Where do I start as a new programmer in First Robotics? A lot of people like to train on the structures of Java and be an excellent Java programmer. I go a little differently with my new programmers. When I'm teaching a student, I want them to be successful fast. So we can make First Robotics programs operate really well without not knowing exactly all the intricacies, like what's actually happening in the background. What's a class, what's a method, what's all these things. And we're gonna use some of those terms a lot, but you don't have to understand it strictly to be able to program the robots. There's a lot of tools out there. So today, I just wanna review where are some of these resources and where are you gonna go, where are these locations to get programming in first. You know, you're not gonna become an excellent Java programmer, but hopefully you're successful and you wanna explore it more and maybe go on into a computer science. So the number one place we're going to go is the docs, FRC Docs. If you Google FRC Docs, it'll be one of your first connections. If we go to this link, I actually only have like 2 more slides after this. It's a really short presentation. You'll be presented with this FRC Docs page right here. And this is really the Bible of everything you kind of want to review. Now we are in kickoff day, so you know reading all of this is going to be very difficult, but at least you'll have a resource to go to. But you're going to go back to your home bases tonight, start loading your software on your laptop, get into your programming environment. If you've never done it before, this can be a very daunting task, but it doesn't need to be. On this page, you can see right at the beginning, step 1, build your robot. Well, we have a build team, and sometimes we wear multiple hats. We're part of the build team, and we're the programming team. But we can skip right down to step 2, installing the software. Also on here, returning teams, their change log we'll review. What's new in 2023. But right here on step 2, you can go right down this list. And the WPI and the people that have written these docs have done an excellent job of just kind of tutorializing step by step. You start on step 1, read through getting all your installers, getting your game tools from NI. This is your driver stations, your Rio imaging tools, your radio configuration utility. You're going to want to download that as well and install that on your machine. That's how you, after an event, you're going to program your radio back to use for home, or even this year, you're going to get those new drivers installed in the radio if there have been any. And then scrolling on down, C++ teams, LabVIEW teams. So no hands. I'm assuming we're all assuming we're going to go Java. Seems to be the most simple in my solution. That's where I've been most exposed to. The difference between all the different languages, Java, Python, C++, is really syntax. They're all very object-based type languages written around a core ideal of creating a little bucket to store some information in. Right here, you go to the installer, and they show you how to install it here, but this will link you out to the GitHub. Finding the release, and scrolling down to your operating system, and download if it's your Windows, a Mac, a Linux type machine. I've already done all these steps here, and these are all released right now. They were put out on the 4th. Scrolling down, it's step by step on how to install it. I'm not going to do that here because it just does take some time. If you're a LabVIEW team, you do go through these steps, so we usually can skip this page. Right down to the bottom, or just go install game tools. Go download the FRC game tools from the NI repository. So you can see how this is a very linear, just keep on scrolling through the list, installing your software, hitting next. This is a long list here. So the next couple steps here too is like, who here uses the Rev product lines? Right, Rev, CTRE. These are what we consider third-party libraries. They don't come installed, so you're going to have to go out to those individual websites, National Instruments, and download their libraries. Now, They have very good tutorials there too to install Phoenix Tuner, the Rev client tool. That's going to get all the code on there, and then they have ways of how to get that in your code. And we're going to look at that here in a little bit when we go create our first robot program. Next thing we can kind of do is look at the overview, because if you aren't new to First Robotics programming and you were programming last year, there are some changes. I'm going to go back to the top level here. We can look at this change log here. And here's a list of things that are new for 2023. And a couple of the major things that I know are going to get a lot of people is in that drivetrain. Oh, yeah, I have a question over here. What's depreciated? Things that they don't want you to use. What they've added. And I said I don't want to go into it, but here are the triggers, all of our buttons. New to command-based programming. So we all kind of have maybe a general understanding of command. We write a subsystem. We write all the methods that we want that subsystem to act on. We write some commands, and those commands we can then map to buttons to trigger these activities. In the past, it was while held, when pressed, a lot of these terms. They changed those terms this year. They're now when true, when false, on true. Right here, on true replaces the when active, while true now replaces the while active. So they changed some of the terminologies in here just to kind of line it up with more Boolean type language. Breaking changes, things that you did last year that if you just import your code, you may have to go review that to get your robot, last year's robot running on the 2023. This list right here. Some of the known issues. They know there's some issues in there. The beta teams out there have been working on this software for several months now, playing with it, writing what they're finding for bugs, and they've been working on it. And there are still some things out there that are very buggy. One of the big ones here that I personally haven't experienced yet is, that's the joysticks right here. It was on here last night when I was reviewing this. Oh, right, top one. Driver station does not detect joystick at startup. So they know there's a bug right now that on some machines, when you start your driver station up, the joysticks may not show up. So that might be something good for your technician when you're going up to an event to pull up your driver station. And it's always a good idea to pull up the driver station and the USB drive and make sure that joystick 1 is actually on joystick on map to number 1 or 0 rather, and they're all functioning. And if not, go ahead and rescan. And then finally, the command-based programming is, since we're all talking about command-based, is there's a great resource here. Advanced programming, command-based programming. This whole article really goes deeper into what different commands types there are, immediate commands, timed, wait till, and all the decorators. The and then or the with timeout decorators that you can add to an end of a command, useful for when you're writing some autonomous commands out there. So great resource to go into and read some. I can say I've probably about once a year I try to go read this command-based programming article just to refresh the head, because yes, I do program a lot of robots, but I miss some things, and there's always something new you can learn. I'm still learning from a lot of the individuals out here. Teaching is one of the best ways to learn, because everyone likes to do it a little bit differently. The other big thing, though, now that was getting the WPI libraries up and running. The other big thing is Git, and I believe Adam over there kind of brought that up there. Is how do we get GitHub? Now, Git is a way to take your code and store it into the cloud, and it's also a great tool to collaborate with. So if you have multiple programmers and one's maybe working on one subsystem, another working on a mechanism of another subsystem, you can be both working on the same code base and not having to copy and paste things back and forth. It'll do the merging automatically if there's no conflicts. So I'm going to show you a little bit. There is a little bit of extra setup that we have to do in VS Code to get it up and working, and it's actually a small software package you have to install. Fortunately, if you went onto Google and you went First Minnesota CSAs, I have a tutorial up there, and also Keith has put up a tutorial up there. If you go to firstmncsa.org, on the side here, and we just type in Git. There should be one VS Code with Git. This was written by Keith from the Fire Bears several years ago, but it's still very good Word tutorial. Wrote an article on there, but if you get anything out of this tutorial here, it's installing the Git SCM. He has a link here. You're going to install this. This is the background software that actually does the backups and the code comparisons, a lot of other great Git tools. So you install the SCM, and then the first time and only one time, you're going to need to enter these two, and I'll show you how to enter these two lines of code into VS Code when you get there. The other spot to look, and there's two things here. If I get back to my presentation, is actually on our the first Minnesota CSA GitHub page. A lot of the CSAs in our area have been posting code snippets and different bits of information up here on here. I just recently added these two Robot Builder extensions. We're going to take a look at Robot Builder. I'm a big pusher of Robot Builder for new programmers. That's how we get past that blank screen, as well as my guide for setting up VS Code. There's a cheat sheet that was included in our kit of parts about 3 years ago that I've scanned in. If you are command-based, there's a lot of different commands for Git. You can download this two-sided little sheet, as well as a PDF or a doc of my tutorial that I run. I've written this tutorial more as a bullet point, not an article. Some people like to read an article, and they do well reading that article. Others want straight to the point. Install Git. Create a new repository. Don't initialize it. This is step-by-step on creating your first Git. And I'm going to kind of run through this. And a lot of these things don't have to happen in this exact order, but you will have to do some items beforehand. So up until this point, any questions for me? Showed you a couple tools of where to get some information. Okay, that's good. So we talked about third-party libraries a little bit, and we're going to go open up. We've installed our software. Let's just say we got our SCM on there. We're going to create our first robot program using Robot Builder. When you open up Robot Builder for the first time, you're going to see a list of tools that WPI gave us. If we installed Rev client tool, it doesn't install anything into, because we can write add-ons for Robot Builder. Rev currently does not add anything to Robot Builder for us, but I've created those those blocks to add that into our project. CTR adds a couple extensions on there, but they're very basic. You can set the Can ID of your motor. That's it. There's a lot of other boilerplate code out there that we always add to our programs, especially with all these smart motor controller devices. I'll show you here in a minute to reset our factory defaults. Because when you got this robot going, you're in a competition, and this motor controller, this Falcon or the Spark Max smokes. We let the magic blue smoke out. We got to grab a new one off the shelf. We put that in our robot. That one off the shelf, what was it last used for? Was it some PID flywheel testing from 2019? We don't know. So we want to make sure we added our code a way to reset that controller. And we can go look at all the revs or CTRE sample codes, figure what those lines of code are. But the add-on extensions that I've created for Robot Builder that are right here in this repository, you'll download, extract this, and copy it into your extensions folder. And I'm going to show you where that is in a minute. So first Minnesota CSA GitHub page. We have a lot of tutorials out there and sample codes for everyone to go into. So with that, let's create our base program, right? Let's get off this blank page. Once we install all of our software, the Rev Phoenix Tuner, or CTRE Phoenix Tuner, Revs hardware client, we're going to have an icon on our desktop called 2023 VS Code. We're going to be presented with virtually a blank page. Where do we start? Well, we could just go create a blank new project with no code in there, and we have to start finding all these samples or start hard coding anything. But I'm going to show you a tool, if you haven't been experienced it, called Robot Builder. We hit the little 3 hamburger buttons here and go Start Tool. Here's Robot Builder. In previous years, there was an old and a new. The old Robot Builder has been removed. It's been depreciated for several years. It's a different command-based model. Let's start Robot Builder here. What we're going to do here is going to enter in a name, and I'm going to call this Kickoff 2023. Enter my team number in there, 4607. I create this project. Now I've already done a lot of things inside here. I'm going to show you where these tools are, but off the left side here we have our palette. We have subsystems, different types of controllers we might drag into our subsystem, all the different sensors that are included with WPI, along with, you can see there's some CTRE products in here. These were added when we installed Phoenix Tuner. So if you don't see these icons in there, you might have not installed Phoenix Tuner yet. The actuators that we can see I have two Falcon FXs. We have the one that CTRE installed and my enhanced version into this palette. The Talon SRXs enhanced, as well as the Rev. So a few items in here that I've added to the palette here. How do we get those items in there? Just have to review here the pneumatics, different joysticks, controllers. The copy I have of Robot Builder in here right now does not have the PS4 joystick control in there, but that was just added right before kickoff. So WPI will add that joystick control in there. I wrote an add-on, and then we've included it directly into the installer now, and a few different types of commands. If you don't see these enhanced versions on there, the reason is, if we go to your downloads folder, Robot Builder extension, you'll have this download Robot Builder extensions master. Click on that, drill in here till you see these folders right here, and copy these 4 folders. We'll just select the first one, do a shift, select the last one, copy. And all of the WPI installers go into a folder into your public drive. And every year they install a new folder. That folder is located in the C, users, public, WPI lib, and you'll see all the different years of software that have been installed on your laptop or your programming PC. In the 2023, we'll go to Robot Builder extensions. It's kind of a lot, and we just paste those in there. Once we paste those items in there, we relaunch Robot Builder, those will show up in our list. So what is Robot Builder going to do for us? Again, I kind of hinted it's going to get us past that blank screen. Instead of having a add text here block where we're going to have to type, we're going to use this GUI, this graphical user interface, to start building out our robot. What is the basic subsystem that every robot has? You should be able to, in the next day or two, when your teams decide what chassis you're going to use, if you're going to be a swerve drive, Robot Builder's not going to help you with theirs quite yet because those modules haven't been built for this. But what drive, I mean, every robot has a drivetrain. I already kind of gave the hint out there. I usually try to get a question out there. But every robot has a drivetrain. So we're going to create a drivetrain and stub this stuff into our robot programming. And the nice thing about Robot Builder, it's error checking. If there's ever a problem, it will highlight it red so you can correct it. And it also only allows you to put certain things in different buckets. So it's constantly checking and only allowing you to do what it believes it can do. So we can drag and drop. I'm going to grab a subsystem right here, drag it into my subsystem. I can't put it in operator interfaces. I can only drop it into the subsystems. I can name this subsystem drivetrain. Now you can see how did I just type that out there? I use a syntax. And when we can't have any spaces in our code. If I put a space in there, when I generate this code, Robot Builder is going to concatenate it down and remove all the spaces. So right now you kind of have to start thinking, how do I want to write my code and how do I want to be consistent? Do I want to use camel casing, where I capitalize every word just so I can get some separation? Do I want to do a snake case where I use an underscore to take spaces in there? Or do I do a hybrid of both? I tend to do a hybrid myself, but that's really up to you how you want to do it. And it's kind of trying to be consistent at best. There is no right or wrong. Some people will die on a hill saying this is the way it has to be. In the end of the day, consistency is probably the big thing. So I created a drivetrain, either using snake case or camel casing. If I have any constants I want to add to it, I can add these things. But right now, our drivetrain and the model I have, or the robot I have in front of us right now, we have a basic West Coast drive, or it's called a differential drive. So instead of drag and drop, because I could just go over here, motor controller group, differential drive. You can see if I right click, I'm only given a menu of things that are allowed to be put in here. So controllers, and I can go differential drive. And you can see this differential drive, it requires some items. It requires some motors. On this particular drivetrain, I have 6 mini sims, all controlled off of some older Talon SRXs. So since I have 3 per side, I'm going to create a motor controller group. Because I really want to treat this one motor, or this group of motors as one. So I'm going to create a motor controller group. Add a controller, motor controller group. I'll call this left motor group. And do yourself a favor. Name things that are, name them something logical, something that will make sense later in there. Don't just leave the default names. What's motor controller group 1? I don't know. This is left motor. I see some laughing over there. So there's been some discussions over there. As well, I'm going to add another motor controller group. I'll call this right motor group. Popping. So we're going to add some motors to here. So we're going to go look at how to get that information here in a second. But right now I know I have, again, 3 Talon SRXs per side. So I'm going to add an actuator. On the left side, I'm going to add just the regular Talon SRX so we can see what options are there. On the right side, I'm going to put in my enhanced versions to see what. Add actuator. Add actuator. Now, if I were doing this for real, I would really encourage on naming these motors left, upper, mid, lower motor. And you'll see in a minute here, these motors are named something to make this code match. But just for time-wise, I'm just going to leave these Talon SRX 1, 2, and 3. And you can see how the code is automatically incrementing the number. It's creating a motor 1, motor 2, motor 3. Over here, I'm going to add a actuator, but I'm going to use my Talon SRX Enhanced. You can see Enhanced 1, Enhanced 2, Enhanced 3. The other thing it's doing is motor 1, you can see it set the Can ID to 0. Motor 2 is Can ID 1. Motor 3 is Can ID 2. What are those Can IDs? Well, in this case, since we're using CTRE, I'm going to fire up my Phoenix tuner. And if the machine's not wired up yet or coded up yet, you can't do this. You can start assigning those in Robot Builder. And I'll show you how you get that off to your programming group or your mechanical group to get set up. Go to CAN devices, and right here we can see the motor left is 15, mid 14, and 13. And then our right motors are at 0, 1, and 2. Where did we come up with those numbers? I have a convention that I strongly encourage teams to use. When you set your CAN IDs, to set your CAN ID to the same port you're mechanical or you're wired into on your control panel, whether it's a PDH or a PDP. The PDH from Rev is a little more difficult because you plug into port 0. You're not allowed to use, if you're using Spark Maxes, you're not allowed to use port 0, Can ID 0. So you might have to come up with like, if I'm using 0, I'm actually going to use Can ID 60 or something. You have to kind of go off into the weeds. So there's a little gotcha there. With the CTRE products, you can use Can ID 0, and even on the Rev, you can use 0 over and over and over again, or 1 over and over and over again, as long as it's a different device type. Because your PDP in the CTRE world is 0, your pneumatic control hub is 0, and now I have a Talon SRX that's port 0. That's fine because they're all different types of products. So the left is 13, 14, 15. I'm going to go over to Robot Builder, go to my left motors, set these to 13, 14, 15. And you can see those regular ones, all I can do is a Can ID. For my right, they were 0, 1, and 2. 0, 1, and 2. There's a lot of other options in here that I can do for these motors. You can see I can invert the motor if I need to reverse it, so that's going to write that code for us. It's also going to reset. I can either tell it to set their factory defaults or not set their factory defaults, which by default we want that set to reset. We can set the brake mode or coast mode. This is going to write all this is going to get all this code for us out there. I have some errors though, and we're going to explore some of that here. The motor controller group. I just got to go ahead and make sure these are all unique motors for this group of motors. You see the left motor group is good. If I go on the right, these little drop downs get populated by the types of devices that I've created underneath it. And a differential drive. I have a left group, and I'll go pick my right motor group. All my errors are fixed. A couple more things we're going to add before we actually drive it into the code and see what this robot builder is going to do for us. Let's add a Xbox controller that I have with me here today. This would be like your driver controller, co-driver controller, what you name it. You set the port of where that you expect that controller to be on. And it can be added on there. You can see how these menus change on. Now, since every robot has a drivetrain, what does every robot have to do in a minimum? Drive. Does it drive autonomously? Does it drive with? So I usually create my first command as drive with joysticks. Again, a naming convention that I like to use is the first word in my command is the subsystem it's going to act upon. So they kind of get grouped up in the list. If this is a shooter, jog, intake, extend, drive with joystick. So I'm going to call this one drive with joy. In the command-based model, a command, you will need to inject the subsystem into it. And that's actually it's dependency injection. We're going to say, this command, here's the subsystem that you're going to work with. Every command, about 99% of the time, you're going to have to require to act upon on a subsystem. And how that works is if you're driving with the joysticks and you hit a button and that drivetrain takes off and does some autonomous command, that new command is going to say, hey, I need the drivetrain too. So I'm going to cancel the joysticks, I'm going to do my thing, and then when I'm done, you'll return it back to the operator control. So we're going to hit this requires. And the only thing we have in here, because we only created one subsystem, is the drivetrain. The smart dashboard button, this robot builder is going to generate a lot of boilerplate code for us. This one specifically, I would uncheck. But you'll see there's a lot of code being written here, and all these buttons will be software buttons on our driver station. So if we don't have a joystick and we still want to test something, we can push it right on the screen using the shuffleboard or whatever dashboard you like to use. Parameters. Now, this is where we're going to add a few things to use our drivetrain, right? We're going to add 2 parameters in here. My speed. I'm just using some words here so we can see they really pop out later. My turn. So these are, the drivetrain usually has a speed and a turning parameter. And then we can do a type. This year we've added a double supplier type to the list here. And what a double supplier is, we're going to inject code into the subsystem saying, here's how you're going to go get this information. We're not just going to inject a static number, like go 50%. We said, go grab this joystick value and then use this speed. So we're going to say this value is going to be a double supplier as well as a turn. And what this is going to do is going to stub in some of the boilerplate code that we're going to go edit here in a little bit. And then it's a good idea to add a preset, even if it's just a default. And this will also, again, just to kind of get us some places to make some changes. I'm going to add a preset. Delete one of these. Call this default. And this is going to be, this is the Lambda instruction that we're going to use. I'm going to leave these just open close parenthesis minus greater than 0. This is just going to inject a 0 as a value, and we're going to actually tell it where the joysticks are later. If I knew exactly what the syntax was, I could use it here, but I'm going to use the power of VS Code to kind of help me. So there's my default. And then finally, before I go, and again, if I forgot, I usually forget this step, but I could make this happen later. We're going to set the default command. And you remember here in my explanation before, this drivetrain, we're driving along with a joystick. We hit a button, the drivetrain takes off and does some autonomous command. When there's no active commands on that subsystem, the scheduler for our robot will say, hey, nothing's active. What is your default? And it will automatically activate the joystick controls back, getting hand control over the drivetrain. You would hate it for this autonomous to end, and the driver goes, oh, I have to hit button A to take back control. So setting the default command enables the scheduler to always turn on whatever you want, always acting on there. And a lot of commands it's not required, but it can be helpful to hold position. So what we're going to hit this, I'm going to hit this Java button, and this is project successfully exported for the first time. It just created this project for us somewhere on the computer. Where did it create it? I should have talked about this in the beginning, but up here on the top level of the project is some of the root level control, our team number, where this project's going to be stored. I could change it if I would like, robots, FRC projects, along with some other defaults, but usually this is really good for as is. I kind of hinted before, we're making our program, but our robot's nowhere close to being made. We can hit this wiring table button. And what this does, it creates a list of everything that we've created in Robot Builder, the names of the devices, the Can IDs, and when I said if we're going to go with the habit of using our Can IDs plugged into the PDP port, now our wiring team knows that that right motor has to be plugged into port 0, port 1, port 2, and if I would have named those motors properly, they would have said, hey, upper motor, left motor, upper right motor. So that's where it's important to create this documentation. And then in the heat of a battle, you're at a meet and you're having a motor problem, you can have this sheet in your engineering workbook that none of us create. And we say, look up this, you know, we should. It's amazing that it's not more expressed. But we have all this documentation to refer to. So let's go open that project and see what we got. In VS Code, if I go File, Open Folder, FRC Projects, I should have Kickoff 2023. Select this folder. The first time this opens, it's going to build a project. We're using third-party libraries, so I'm already anticipating this build to fail, because there's something we're going to have to do to make this, to import these in there. Can anybody tell me how that's going to be? No, because see the build failed. Let's go browse the code a little bit, and we'll fix that here. In our subsystem folder, we have a drivetrain. We have all the CTRE imports there. It knows that this robot builder obviously boilerplated this all out for us. We have all imports up here. Created our objects, defined our motors, set the Can IDs, added it to the group. Here's our enhanced version, the Talon on port 0. Config factory defaults already programmed in here, set inverted, neutral mode. You can see how using that enhanced version just put all this boilerplate code in there for us. What Robot Builder does not do a great job at is formatting it. You can see the indentation is driving your OCD crazy right now. It does for me too. I think it's new this year. Back at FRC Docs, there is a formatter that's included in here in the code now. I just discovered it last night. I haven't been able to play with it too much, but it should do all this indentating and making sure that you keep your code base consistent. I think somebody over here said that earlier, keeping it consistent. But the reason the drivetrains are here, our command. We have our command, drive with joysticks. We see it's all of our imports, these private buckets, our constructor. It's bringing in a double supplier, and the subsystem drivetrain. A command typically has these areas. It has an initialization area. This initialization, when you hit a button or the first time this command is activated, this initialization runs one time. This might be good for writing out some debug information out to your console, resetting an encoder, reading some value that you're going to want to act upon before this command executes. This execute method is called by the scheduler every 20 milliseconds. This is where we're going to update, we're going to get some information and act upon our subsystem. It can't boilerplate this code, so these are the areas that we have to fill in. The end method, when this command ends, this is what executed one time, or if it's interrupted by another command, this method will execute. This is where we can shut off our motors, clean up after ourselves, write out to the console saying, hey, this command ended, do some debugging right in here so you can get some feedback out there. Is finished. If this is some autonomous command, you could write a statement in here, this false statement, and change it to if my encoder is greater than or equal to some set point, end this command. So this command could then finish on its own. Or the gyro value equals some value. Run when disabled. Obviously, we can't drive our robots when they're disabled, but there are some things that you might want to activate on your robot. Say like changing the colors of your LEDs if you're doing some indications right there. You can run code, your robot's running code, and certain functions are enabled where changing a digital output or writing some message to Arduino to change your RGB LEDs to your alliance color. You could, if you enable this, you turn that false to true, this command will execute even if your robot's disabled. Now if you try to run a motor, it's not going to work because in the RoboRio, that bus is actually disabled as well. So there's safety measures on here. But there are certain commands, if you do want this to work when the robot's disabled, you can do those things. In the robot container, we're doing all right on time for what I'm expecting. Stubbed out all our stuff. Created our drivetrain, created our joystick for us. Started up a auto chooser that we can add commands to. Put some buttons on our dashboard for us. Configure default commands. This is where we're going to drive with joysticks, and we're going to change this code here in a minute. But let's go fix this error here. So what we have to do is we have to import our vendor libraries. There's 3 ways of doing this. You can go up into here. I think it's Manage Vendor Libraries. Select this option. I typically go to Build Gradle, right-click, Manage Vendor Libraries. Rev, you want to look at their get their JSON file and how to do their stuff, either check for updates online. But since I installed the Phoenix tuner, and this is still the beta Phoenix stuff, I'm going to go offline. I have them installed on my computer. I'm going to just select the CTRE Phoenix libraries and import that into my project. This will build, and now you can see my project is all happy because now this project knows how to work with those libraries. Well, is the robot on? Yes, it is. So we kind of explored the robot here. One of the neat things that we did with all this boilerplate code is I'm going to go ahead and deploy this. Have I written any code yet? No, I've kind of dragged and dropped, done some things. I'm going to dump this into the robot. And we're just going to see if I got things mapped correctly. Pull up my driver station. This comes up to on the FRC Docs. It's a tool that I rarely use, and I really need to start using it more, is the debugger. Running your code in debug mode and setting breakpoints. There's a good article on how to do that with our robots. But typically when we write a bunch of code, we go into test, we go into teleop and we start testing our robot. But there's also this option, who here has never used this test button on the drivetrain? Many of you have, many have. Well, if you haven't, this test option runs all these, let me go file new here. There's these little widgets that were created by Robot Builder for us, already installed in there, where I can enable the robot, and I can say, right motor, add some power, forward. These motors, I'm gonna go forward. So I can start testing a lot of my outputs since I use Robot Builder, and it created these child objects that are only accessible at on the live window tab when in test mode. So I know my motors are working. I'm looking at my lights, they all seem to be blinking. I'm assuming they are, they look right. So now I'm going to disable this robot, and we're going to actually start writing some of our first lines of code. There's 2 ways to approach this. I like to work from the bottom up. I like to start in the subsystem, build my methods, go into my command, create my commands to work with that, and then finally go to robot container and link everything up. But you could go top down too if you already know what you have. But with only a handful of lines of code, we're going to go into the subsystem here. And right here at the bottom, we're going to write our very first method. This method is some instructions that this subsystem can work on. And this subsystem is very simple. It just has a drive train. So I'm going to create a public void my drive arcade. And I spelt that very wrong, huh? Typing and talking, right? So that public, difference between public and private. Anybody? I'm gonna wait on you, Adam. I know you know. One more time. Yes. So to repeat that, the public methods are accessible outside the class, so your commands can access it. Anything private is only local. Nothing outside of this class can access it. Alter the thing at the top. I don't know if I'm not quite following that exact scenario, but Robot Builder is programmed by volunteers. It does have some bugs on there. So you start dragging, oh, I didn't mean to add this object to this subsystem. I want to drag and drop this over there. It can be done, but it might explode on you and do some unpredictable things. But I'm not quite sure. Yes, I'm going to get to that here. Okay. Yep, we'll get that. We'll get to that when we get into the robot container. His question there. He was basically saying, does Robot Builder so overwrite our code that we've created? So that's well, I'll talk about that right now. So as I was scrolling through this, you've seen some of these areas. Let me get a good example where I can get both. This begin auto-generated code, end auto-generated code. These blocks of code are what Robot Builder are controlling. If I go back, yeah, usually I'll do that in here. I'll go. Hello. I'll write a line of code inside of this begin and end. Hello world, and I wrote this outside of there. If this little X is a round circle, it's not saved, so I want to save it. I'd like to turn on auto saving, so as soon as I'm done typing, it automatically saves it to the file. But if I go to Robot Builder here and I regenerate code, it just went and updated all those blocks. You can see my hello is gone, but my world is still there. So whenever you're writing code and you're going to make changes inside these blocks, you have to take control, take it away from Robot Builder. You can either delete those two lines or simply add a little dash in front of there. Hello. It's saved right here. If you don't hit save and it's you do the Robot Builder, now there's a conflict in the file. So that's why saving it is important. If I go here and hit generate Java, you can see that hello is still there. And that's because Robot Builder is actually looking for this string right here and trying to do a string compare. And when it finds it, it updates that code. If I ever want to return it back to Robot Builder for some reason, I can take that little tick mark out, hit the Java button, and now Robot Builder will now manage that section again for me. Is that what you're kind of getting at, James? All right. But down here at the bottom, we're going to create our methods. Public void myArcade. The void, what that is this method returns no value. If this was actually a getter, it might return public double get gyro angle. You put the type of data it's going to return in that void spot. In this case, it's going to act upon our differential drive, arcade drive. And you can see it's two different values. Where are these values going to come from? We're going to actually inject these values into this method. So I'm just going to call this x speed, just as it kind of was telling me there. These variables can be whatever you want them to be. And z turn. These variables haven't been created. We're going to pump them in through this parameter right here. So I like to use the IntelliSense. If I click on the error and hit the little light bulb, I can create a local variable just inside this method. I can create a field, which is part of this whole scope of this class, or I can create a parameter. And since Arcade Drive knows it's supposed to be a double, it just created this double x speed for me. I'll do the same thing here. I don't like to type. When I'm programming, I'm usually about 5 steps ahead of my fingers. So the quicker I can get caught up onto my brain, the better. And now we can see that this method right here has been created. It's going to take a speed and a turn value to drive this robot. That's all we're going to do inside of our drivetrain. We're done inside of there. We created our method and our rules. Go to the command for drive with joysticks. Coming inside here, we can see that the constructor is going to send in a speed as a double supplier, a turn, and the subsystem in here. It's copying those into these local variables, or these private local variables for the class, so we can act upon them later. Initialize isn't going to do anything in this case. We're not just resetting any encoders, but we're going to act upon our m_drivetrain. That's the subsystem that has been passed in and copied to dot. And since I use that word my in front of my my method, this IntelliSense gives me everything that I could possibly use on that drivetrain. But if I just type in my, you can see that that method that I created floats right to the top, and I can just hit enter there, and I have a drive arcade. This is requiring a speed and a turn value. Well, that speed is coming in on that m_my speed. Remember, that's a bit of code that's coming in. So we're going to say dot get as double. Whatever that code coming in there, get the value of that lambda instruction as a double. And the same thing over here, m_my turn dot get as double. One of the big things you'll see in the breaking is we're going to have to check our joysticks and stuff, and we're going to go through these. We're going to show you how it's wrong, how it's fixed, but we want to make sure when we're programming a robot that when we input a positive number, the robot goes in a positive direction. If our elevator is supposed to go up, we should be giving it a positive power. When it's going down, it should be going a negative power in our command. The other thing you should be doing, if we're looking at our lights and our smart motor controllers, green should be forward, green should be positive, green should be logical. So when you're looking at your drivetrain and all your devices, you can look at those lights in there and say, hey, there's a positive number coming in there, it's doing different things. So we want all these things to be synchronized. Also very important when you get into PID control, to make sure your input and outputs are in phase. When this command is interrupted and ended, we want to make sure we're good citizens here and call the my drivetrain dot my arcade and just set it to 0, 0. You can imagine if we're driving a robot full speed and some autonomous command takes over the drivetrain, but we didn't update the speed of that robot's going to continue to drive at that speed and try to escape the field. So we just want to shut down this method, this command, and hand over any control to the new one. Be good citizens. Yes, the safety timeout will time out eventually, hopefully, but let's clean up after ourselves. Over here in the robot container, this is where we're going to modify this default command. You can see right now it's set to, we're just going to input a 0, 0. This is where we're going to go get our Xbox controller, which we called 1, and get the raw data ports. So Xbox controller dot get raw access. I like to use the get raw access method. You can get Y, you can get Z, you can do all the different things out there. This is the way I typically go. There's no right or wrong. How do I know which access I want to use for my speed? If you haven't explored the USB tab here, controller 0, I'm going to make sure, I'm going to use this stick right here, and I can push up and down. I can see it's access 1 is activating. The other thing is look at when I push up. Which way does that access go? Down. So that means I'm actually inputting a negative number right now into my code. So I want to invert this joystick. That's really simple. So it's access 1, and I want to invert it. So we'll go access 1, and I'm just going to invert that right away. Xbox controller1 dot get raw access, and then my turn. In the past, my drivers have used from my previous team. I'm not sure what we use on CS anymore, but it's really driver preference. We use this stick left and right, and you can see that's access 4. Now, this is one of those breaking changes that they did to the differential drive. In the past, I could just use this as is, but they've now changed the differential drive turn to be in phase with the right-hand rule. A lot of our 2D pause, 3D pause, all this really high-tech position that we're doing on our fields nowadays that they're giving us access to, and they're creating these libraries for us, they all required this right-hand. In industry, we use the right-hand rule for direction of X, Y, Z coordinates. So if you stick your hand out like a gun right here, their pointer finger is the X positive, your thumb is the Z positive, and your middle finger, when you come straight out, that's Y positive. So that's your X, Y, Z coordinate on the field. So now when you're referencing, when you're doing 3D pose, this is the coordinate, the system that they're using. The other thing they're doing is rotation. So we're going to be turning our robot. To do the right-hand rule, just imagine this is my right-hand thumb. What I'm going to do is use my right hand. I'm going to point my thumb in the direction of rotation. So in this case, if I wanted to go X, I would point my thumb in the X positive. You can see how my fingers would wrap around my finger. That would be the positive direction. So in this case, if this is Z, or straight up and down is Z, if I put my thumb in the positive direction of Z, you see my fingers wrap around in a positive direction. Now, if I hit right, you can see which direction I go. Negative. Well, actually, that should be a positive too, shouldn't it? Because I'm going to be turning, or sorry, if I hit left, I'm going left on my joystick, and it's going negative. Well, that's actually positive. A left-hand turn is a positive direction. So I need to invert that joystick now too. In 2022, you didn't have to invert this one. So we're going to go ahead and invert this right away. Oop. Access 4. I'm going to deploy this code, and while it deploys, we're going to have a little talk about what I did wrong here. What's going to happen if I go to Robot Builder, I create a new subsystem, I start doing all this stuff, and I generate code? Yeah. Why is it going to be? I'm gonna have you hold for a second because I know you know the answer. Why is it going to be? Okay, go ahead. It's between the auto-generated headers and footers. So if I went into Robot Builder, it would overwrite everything I just wrote in here. So either move that out or take this away from Robot Builder. You can see how you could get some really complicated math or some complicated algorithm going, and all of a sudden it's gone. Like, oh no. And usually as soon as you hit that Java button on the screen, you're like, what disappeared? You know, so I'm working with teams that use Robot Builder, and I come in there 2-3 weeks later, like that Robot Builder is, we no longer use that anymore. So Robot Builder is good for the first week, or to stub out some prototype code and copy over to your main base. But after a week or two, kind of abandon Robot Builder because unless you're the only one touching it and you know exactly what it's going to do. So let's go into our drive. We're going to do this just right. Teleop, enable the robot. I'm going to push forward. That's exactly what I expected, right? What color are all my lights on here? They're all green. So the controllers are correct. Green's forward. That side is correct. This side's wrong, right? And I believe this is the left side. So we need to invert all of our motors for the left side. All 3 of them. Disable. Look at that. The left side motor group, I don't have an invert right here. That's kind of unfortunate, right? So I'm going to have to go into the code and create all of those. Usually I have a script. I always do it the right way. I'm gonna call that down. I'm gonna call that forward for today, into the dirt ground. So when I'm driving, so that makes this one correct, right? And the other one would have been wrong. I'm gonna go into my right side motor, and I'm gonna invert all these. Check that box. Check that box. Check that box. Did I take that away? Yes, I did. Generate the code. You'll see over here in the drivetrain on those enhanced versions, this inverted was set to true for me. I could have went in here and just typed in true, but remember Robot Builder owns this part of the code right now, so I'm just letting Robot Builder manage it. If I would have changed this code right here, I would have wanted to go and take that auto-generated code header footer out of there. Redeploy. If I didn't have this enhanced version, I would have had to write those lines of code up here in that section for each one of these motor controllers. Enable. And now when I push positive, which is down, you can see the robot's driving into the ground, which is forward. If I hit left, actually I think that is inverted right now. It is. Guess in this case, since I've inverted all my logic, I did the wrong thing. But you get the idea. We can start to test things, go negative, positive, make sure that our positive information is forward, negative. And the great thing about Robot Builder is we can start creating all these individual subsystems. We could go create a whole other program for just our mechanism, A, mechanism B, mechanism B. My days in 3244, when we went to week 0 for power up, we went there with drivetrain code, elevator code, manipulator code. They're all separate. And all we did is drag those modules over into our code base as the week 0 went on there and added one bit at a time. And the nice thing about that is if we're having trouble with our elevator during the season, we could just download just put the elevator code in there, get rid of all that other noise, and just focus on the elevator. So you can drag these modules, these classes into your program and start adding them using this template. The nice thing about Robot Builder is it puts all the blocks into the right area, and it gives you something to follow. Another good spot as a new programmer, before I take too many more questions, is if you go into here and create a new project, template, or grab an example, Java, GearsBot. I probably have that, and you can create an example code here, and I think I already have, to be honest. It's 2022. Put it in this folder, call it GearBot. This here is a really good command-based example, and it's a good place to follow, kind of trying to find patterns, because when I'm looking through code, I'm looking for the patterns. So we got the Java, a bunch of different commands that they created, subsystems that they created. And the great, what my point was right here is once we make all these little individual commands, like a claw open, claw close, arm up, arm down, all these really small little commands, we can start to stitch them together and create this prepare to pick up sequential command. This is add commands in, again, this is sequential commands. So the first step is going to open the claw, and then in parallel, it'll put the wrist to a point and an elevator to a point. There's I think this autonomous. Here's the entire autonomous command. We can start to stitch these individual small little commands that work really well on their own. And prepare to pick up is another sequence. Then it does a pickup. Then it sets the distance to the toolbox. And it starts to stitch all these commands together, making more and more complicated. It's mapping all these individual to either physical buttons on your joystick or soft buttons on your touchscreen or just your computer dashboard. And again, Robot Builder, when I didn't show that because we didn't have a command, but I can create a button. I can say this is going to be the Xbox controller 1, button A, the command I want it to run, which we wouldn't do drive with joystick, and then when true or on true. And now, if this command wasn't the doing this, default, save, close, generate Java. Bad naming. Don't call it Xbox controller button 1. Call it button A or something like that. But for the hint of time, in our robot container, you can see Robot Builder just created this joystick button for us, mapped it to button A, and now when true or on true, it calls this command for us, passes in the variables that we'd typically use, along with some constructors. So with that, in about probably an hour from now, we'll all learn the new game, but we'll have to get ready to watch this new video. But any questions for me, either in this group or you can pull me off to the side too. I hope Robot Builder can get you past that blank screen. Again, to find more information, you can check out jumpstartrobotics.org. This presentation should be pushed up on there, along with some of the other ones that are up there, as well as the past 2 years of COVID. We've put a lot of videos up on there when we're doing our live stream. So go to jumpstartrobotics.org and our YouTube channel of Jumpstart Robotics. And there it is. Any questions? Otherwise, enjoy your day and good luck for your season. Come up. There's one over there. Do you have to get a thumb drive for what? Robot Builder is installed with the WPI package. If you're going to use my extensions, you'll go to GitHub, download that extensions package, extract it. So however it takes to get it over, I don't know the specifics on your machine. I can't confirm or, yeah. On a netbook? A Linux laptop? Yeah, WPI works on there, so it should be fine. Yeah. Oh, they're adding Linux stuff now, but there's a Linux installer, but I have not tested it on there. I've only tested it on Windows. Yeah. Excellent. Adam? Pardon me? That, I believe, still is Windows, huh? Excellent question. I don't have that answer. It's kind of outside the scope of my immediate knowledge. Let's go see. Game tools. Windows only right now. Yeah, there it is. All right. Well, with that, thank you. And again, I said good luck. So let's get charged up, I guess, is the cheesy word to say. Yay.